Let's go ahead and work through an example problem. Say we have a mass on a spring. We're going to go ahead and put it on a frictionless floor, and we're going to say its neutral position is at 500. This is actually going to be a unitless problem. Just the way I coded it up, the spring comes to, or the mass comes to a rest at 500 pixels. We're going to actually visualize this one. And we're going to give it a displacement of 100 pixels, but really this is, at the 600 position. So x naught is equal to 600. And then so we know that delta xi is equal to 100. And then we also know that f is equal to negative kx. Oh, we are letting it go from rest, so initial velocity will be 0. F is equal to negative kx, and then so acceleration is equal to f over m, and then velocity is equal to v naught plus a delta t, and then x is equal to x naught plus v delta t plus let's see here, erase. There we go. 1/2 a t squared, delta t squared. So let's go ahead and code up the spring mass system. We're going to use pygame, which, if you can't tell from the sound of it, is a Python package to help you make video games, but it's also very good for rendering 2D graphics very quickly. And we need increased precision, so we're going to import the decimal package. We'll just do one of these because we need a lot of it. And then get context is a part of the decimal package. And we're going to set the precision really high because sig figs matter in simulations. And then let's go ahead and initialize. And clock is a part of pygame, which helps us with timing the simulation and making it a little easier to look at. And I want to set some constants here. What we're doing is we're using 3-digit or the 3-number coloring system, where we're using RGB colors. So we're saying, I want full red, full green, full blue, and I also want 0 red, green, and blue, and that's just for white and black. And then we're going to make the actual screen. So it's going to be a spring mass system, and it's just going to kind of go back and forth. So we don't need a very tall screen, but we do need a wide enough screen to visualize the whole thing. So let's go ahead and see if this compiles. Yep, looks like it compiled all right. Good, or we're not compiling, we're just running it. Anyways, so I want to set my values now, and remember I said we're going to set it to 500. We're going to set the center or the 0 position at 500, and then we're going to calculate or track the x displacement. Looks like I initially started at 400. That's okay. I'll be true to the problem. We're going to set the initial displacement to 100. Oh, that's small. Yeah, I'm going to set it to 400 just because we really want the spring to go back and forth a whole lot. We want to be able to visualize that. And then the initial velocity is equal to 0. And the mass is equal to 10. There we go. And then our spring constant equals 10 and decimal 10 as well. And we need delta t to just keep ticking through the simulation. Decimal 1. So these are the initial values of the system. There we go. And we need a variable called running. And we can go ahead and start calculating things. So we know the initial position of the spring, or of the mass, is equal to x position equals m center minus x displacement. And then what we're going to do, I want you guys to be able to see this. There we go. What we're going to do is just continuously update the position of x. So while running, and we know f is equal to negative k times the delta x displacement. And we know acceleration is equal to f over m, and v is equal to v plus a times delta t. And the x position is equal to the old x position plus v delta t plus decimal. This is one thing that's annoying about high precision. You have to continuously use decimal a times dt times dt. So that's dt squared. Let's just be fancy about it. And there we go. This is really all we need. And for I in range 100. What I'm going to do right now is print x displacement, just to show that this works. And if we go over here, right, so we have our displacement, and I mean it's basically gibberish just because I'm using such high precision numbers and all that, but that's not the important thing. The important thing is rendering this whole thing. So for event in